this on your test. So it says the volume of a spherical air balloon expands as the air inside the balloon is heated. Okay, the radius in feet is modeled by a twice differentiable function r. Okay, all that twice differentiable means is that the derivative you can take and the second derivative you're allowed to take. So all that means is you can take the derivative twice. Okay, then it says the table gives select values of the rate of change of the balloon, blah, blah, blah. The radius of the balloon is 30 feet when t is 5. Okay, part A. Estimate the radius of the balloon when t is 5.4 using a tangent line approximation. What do we do when we need a tangent line? What two things do we need? A point and a slope. So the first thing that I'm going to do for part A is I'm going to find a point and a slope at 5. Now, question. In your chart, what is given to you? Is it the point or the slope? It is the slope. How do we know that the chart is the slope? Because this is r prime. This is the slope. So at 5, what's the slope? 2. So my slope is 2. I got that from the table. Okay, well then I need to know the point. Now if the slope is r prime, what would the point be? Regular r. And what does regular r stand for? The radius of the balloon. Where did they tell me the radius of the balloon at 5? Last sentence. What does it say the radius of the balloon is when time is 5? 30. So now I have my point. I got my slope out of the chart. Then I'm going to write the equation of my tangent line. So it'll be y minus 30. 2 is my slope. T minus 5. And actually instead of a t, maybe just put an x. But no, x stands for time. Okay, then it says, estimate the radius of the balloon at 5.4. What do I do with that decimal?
Plug it into the t.
Plug it into the tangent line. Very good. So I'm going to plug it in right there. What is 5.4 if I take away 5? Okay, so y minus 30 is 2 times 0.4. What's 2 times 0.4? 0.8. And then what do I do with the minus 30? Add it, so y would be 30.8. Okay, that's a tangent line approximation. Hopefully we remember how to do that. Okay, then the second part of the question says, is your estimate greater than or less than the actual value? We need to know concavity for that. Look at your paragraph. They have to tell you that. Yep, what does it say right here in the middle? R is concave down. So if R is concave down, and I draw a tangent line onto a concave down graph, my tangent line is going to be over. Very good. So I would put R is concave down. So tangent line is an over estimate. Okay, they told me R is concave down, though. I wouldn't have known that if it didn't say it. Good? Okay, part B. It says find the rate of change of the volume with respect to time when t is 5. Okay, this is a related rate. So find, given, when, and then the equation. Okay, what are they asking me to find if they want me to find the rate of change of the volume of the balloon? dV dt. Because I want the rate of change of the volume. Okay, and then what did they give me if they told me here what r prime is? What is that measuring? That's another way of saying dr dt. Very good. And what was dr dt at 5? 2. We already know that from before, right? So we were given dr dt in the chart. Okay, and we know that it's 2 because we're looking at time 5.
Didn't we know that like last year?
Yeah. So now that we've learned enough crap, you're going to start seeing AP questions. And so this is just an AP question where now we can actually do all the parts instead of only being able to do little pieces of them.
So yours like rambling 20
Yeah. Now, why did I put it in here? Well, eventually we're going to do a right Riemann sum, and that's in this unit. Yeah. So that's why I picked it, was because there's a Riemann sum in it. But you're right, a lot of the other stuff is kind of throwback. Also, there is a tangent line estimation on your test. So you picked a good problem to review. Then from there, your when would be at time 5. Okay, then they gave me the equation, volume equals 4/3 pi r cubed. What's the derivative of v called? dv dt. On the other side, I times the 3 down. What's 3 times 4/3? The 3's would cancel. It'd just be a 4 pi r squared dr dt. Okay, then I'm ready to plug in. So 4 pi, what's my radius? We found it earlier. What was the radius at 5? 30. And then what's my dr dt that they gave me in the chart? 2. And I would just leave it like that. Now let's talk about units. The radius is measured in feet. What would the volume be measured in? Not feet, feet cubed. Yeah? Because remember, this is a volume per minute. Okay? So 30 squared would be 900, times 2 would be 1800. You could times it by 4 if you care, but I'm just going to leave it. Get the idea? Okay, part C. Yeah? Now, what if it was area? It would have been feet squared per minute, right? Okay, so now we're on to the stuff that you just learned. So part C says, use a right Riemann sum, okay, right Riemann sum with 5 subintervals to approximate the integral. So integral 0 to 12 r prime of t dt, approximated by. Now, first thing I want you to check for are your delta t's, or your delta x's in this case. Okay, are they the same every time, or are they changing? Okay, they're changing, so I can't do the short formula. Which one do I skip if I'm doing a right Riemann sum? First or last? Right one, you skip the first. So, from 0 to 2, how wide is it? 2, and then what's my right side? 4. So I do 2 times 4 plus. Okay, next one. Okay, we're going from 2 to 5. How far is that? 3, and then what's the right side? 2, right? Okay, then for my next one, I'm going from 5 to 7. How far is that? What's my right side y value? 1.2, right? So I'd have 2 times 1.2. Okay, then from 7 to 11, how far is that? And my right side is 0.6. And then my next one would be from 11 to 12, how far is that? 1 with a right side of 0.5. Make sense? So remember, for a right side, I'm going to even put it on here. Okay, remember, you skip the first y value. Okay, then the second part of that question says, using correct units, explain the meaning in terms of the radius of the balloon. Okay, what are my units measured in my chart? Feet per minute. When you integrate feet per minute, what do you get? Feet. Feet that what changed? The radius of the balloon. So you would say the integral represents the number of feet that the radius of the balloon changed while it was heating up, whatever, over what time period? From 0 to 12 minutes. Okay, so I'll write it down. So I'm going to put here, the integral represents the number of feet the radius of the hot air balloon changed over 0 to 12 minutes. Okay, because remember, if this is in feet per minute, when I integrate, I just get a number of feet. And it's the number of feet that what I'm measuring changed. So I'm measuring the radius of the balloon. It's going to tell me how much the radius of the balloon went up. Okay? Yeah?
It's only because on the top it's minutes, like that.
And remember, when you do area, you're multiplying length times width. So it'd be minutes times feet per minute. You just get feet.
Oh, like,
Okay.
2 times 4.
Mm-hmm. Yep. So this is measured in minutes. That's in feet per minute. So when you multiply, you just get feet. Okay, last part of the question. Is your approximation greater than or less than the real integral? Remember, you have to draw a little picture. So look at your table. Are your values going up or down? Okay, they're going down, and which side did I use, a left or a right side? So if I draw a down graph, and I do a right side on it, just like we did in your notes, I'd be picking this side cut across, this side cut across, this side cut across. That's an underestimation. And I wouldn't worry about trying to memorize it. I would just remember, either draw it going up or down, and then just pick the same side that you used and sketch a graph. So let's explain that, and then we're done with that one. Okay, so we said it's an underestimate. Then I'm going to put r prime of t is increasing. So the right y value is always the biggest on each interval. Okay, because my graph was increasing, that means my right side is always the biggest, and that's what I used to make my rectangle each time. Okay?
Wait, is it decreasing?
Crap, it was decreasing, thank you. Because our graph was going down.
Would it be always the smallest?
Yep. Oops. Thanks. Okay, it's an underestimate because r prime is decreasing, so the y value is always the smallest on that side, on the right side.
Around 10.
I know. Dang. Got it?
Yeah.
Okay. So I'll tell you, there's not a related rate on your test. You do have to know over, under. You have to know how to do right Riemann sums, and then I think there's one tangent line. So you should know how to do part A, but it's extreme. I think it's even the radius of a balloon again. Like, it's a very similar type of question, okay? Yeah. I mean, they'll be on the AP test, but they're not on your test tomorrow. The other one I just want to make sure we at least talk about. We don't have to finish it if y'all don't want to, but look at number 3. Okay, in your chart you have velocity. They're asking you in part A to find V prime. What does V prime stand for? Derivative, but I don't have an equation. So what does a derivative stand for? A slope, and there are 2 types of slope. You can take the derivative if you have the equation, but what about if you have a table? Starts with an A. Okay, now where would 16 fit between?
12 and 20.
On 12 to 20. Okay, so make sure that you're careful about that. Okay, if they ask you for a derivative, that's a slope. The best you can do with the table is average rate of change. Okay, then from there you would say, okay, well, I'd want the velocity at 20 minus the velocity at 12 over 20 minus 12. Velocity at 20 is 240. minus velocity at 20, or at 12 is 200 over 8. And I'm just going to leave it like that because I don't feel like doing it. Now, part B, how do you explain the meaning of this? You should recognize this one. Integral of velocity's absolute value. What does it mean? Total distance traveled. What would it be measured in if this is meters per minute? Meters over how many minutes? 0 to 40. So you would say that represents total distance traveled in meters over 0 to 40 minutes. Okay, then when you do the sum, they tell you to use a right Riemann sum again. What would you change in the table because of that absolute value sign? Make sure that negative 220, you change it to a positive because of these bars. Okay? So in order to do it, you would say, my width is 12. Who gets skipped? 0 is the first, so it'd be times 200. Plus 12 to 20 is 8. Right side is 240. 20 to 24 is 4. Right side is 220 because of the absolute value bars, you switch it to a positive. And then 24 to 40 would be 16. Right side is 150. Okay?
Wait, so on the left side, if it asks for left, we just skip the last one. Right?
You'd skip the last one and you'd use all of the other ones,
And we don't
correct?
solve it out.
You don't have to solve it out unless it's multiple choice. Okay, y'all have like 1 minute left.
Wait, what do you need a calculator for?
Your second test is multiple choice, and so you have to be able to add it up to pick the answer you want. You don't have any new skills on the calculator besides taking derivatives, looking at graphs, the same stuff you should already know how to do. Good job!